Hello everyone and welcome to our channel. Today we'll be looking at systems of equations, otherwise known as simultaneous equations. Systems of equation has many applications in engineering and sciences. I'll talk about some of the applications later on in the video. But when we talk about systems of equation, as the name implies, we're talking about a situation where we have more than one equation, right? So, for example, we could have 2x plus 3y is equal to 10, 3x plus 4y is equal to, let's say, 15, right? So if you look at this equation, this is not all we can have. We can have more than two variables. We could have x, y, z, and so on and so forth, right? When we see these systems of equations, we can solve them using mainly three methods, right? So one of the methods that we can use to solve this kind of equation is what we call the elimination method. The second method is the substitution method. The third method we could use to solve this problem is the graphing method. So today we're going to look at these three methods of solving these systems of equations, primarily made up of two systems of equation. So let's focus now on the elimination method as the first method. So with the elimination method, there are some steps that you have to take to solve the problem. First, you have to find a way to make any of the coefficients of either of the variables the same. The second step is to subtract or add both equations together. The third step is to solve the resulting single equation to obtain one of the variables. And then with that, you can substitute that in the fourth step. You can substitute what you got in the third step into the fourth step, where you can now find the final variable now. So it's easier to see this with an example, right? So let's take an example. For example, let's say we have 2x plus 3y is equal to 4, and let's call this equation A. And we have 3x plus 2y is equal to minus 4 as equation B. So if we look at the first step, you try as much as possible to find a way to make one of the variables, the coefficients of one of the variables, the same. So by looking at this equation, we can choose x, for example. What do we do to the first equation to make it the same as the second equation? You can see that clearly we can multiply the first equation here by 3 and the second equation here by 2. If we do that, what do we get? We now get 6x plus 9y is equal to 4. It's equal to actually 12. So if we do that, just a minute here. So we get 12. the second one we get, if we multiply by 2, we get 6x plus 4y is equal to minus 8. And now we see that the coefficients of the first equation and the second equation becomes the same. So let's call this equation C and equation D. Now at this point, now we can easily subtract these two equations. So if we subtract these two equations, what do we get? 6x minus 6x gives us 0. We don't have to write it down. But 9y minus plus 4y gives us 5y is equal to, we do the same thing here. So we have 12 minus 8, which gives us 20. So if we solve that correctly, we should get y is equal to 20 divided by 5, which is going to give us 4. Now that we have the value of y, which is one of the variables, we can now take that and put that into one of the equations. The easiest is always to go with the first equation. So if we do that, we're going to have 2x plus 3 times 4, since our y is equal to 4, is equal to 4. So therefore my 2x is going to be equal to 4 minus 12, right? So my 2x now is going to be equal to minus 8. Therefore my x is going to be minus 8 divided by 2, which is minus 4. So now I've got the value of x and y. So definitely my x now is equal to minus 4, and my y is equal to 4. In mathematics, it's always advisable to do some check if you can. So let's do a quick check to see if our answers are correct now. So what do we mean? So to verify that these values are correct, we put the values of x and y into equations, the previous equations. So if you see that, we can say 2 into minus 4 plus 3 into 4 should be equal to 4. Let's see if that is correct. So this is going to be minus 8 plus 12. Is that equal to 4? The answer is yes. That satisfies the first equation. I always say don't do it just for one equation, you have to do it for both equations. So try it out now for the second one. Let's try it out. So 3 into, we have minus 4 plus 2 into 4 should give us minus 12 plus 8. And if you do that correctly, you should get minus 4. So you can see that for sure the left hand side of the equation is equal to the right hand side of the equation. So we're now pretty sure that we've got both of those the variables, the answers for the variables correct now. So that's pretty much the elimination method. Now let's see if we can go in and look at the other methods used for solving such kinds of equations now. The next one we want to look at is the substitution method. So with the substitution method, our aim there is to see that we make one of the variables the subject of the formula, right, in one of the equations. Then we substitute what we just made the subject of the formula into the second equation as the second step. The third step, we solve the resulting equation that appears from step 2, and then the fourth step, we try to use the answer we got from the third step to kind of substitute into one of the last equation, right, and try to get the other variable. Again, as before, it's easier when you do it with an example. So let's try using an example to see exactly how this works. So let's use the same example as before. So we have 2x plus 3y is equal to 4, and we have 3x plus 2y is equal to minus 4. Again, let's call this equation A and call this equation B. So if we want to use the steps, the first step I explained before had to do with making one of the variables the subject of the formula. Let's pick equation A now, right? So if we do that, if we pick equation A, let's pick equation A. If we do that, we're going to get, if we make x the subject of the formula, we're going to get 2x is equal to 4 minus 3y. Therefore, my x is going to be 4 minus 3y divided by 2. Now that we know this, we can substitute. You cannot substitute to the same equation, right? You have to substitute to the second equation now, right? So if we do that, we're going to get 3 into 4 minus 3y divided by 2 plus 2y is equal to minus 4. So you can see that this has a fraction and we want to take that out. So what's the easiest way to take the 2 out? We just multiply the equation by 2. If we do that, we're going to have 3 into 4 minus 3y plus, we're multiplying by 2, so we get 4y is equal to minus 8. So if we multiply through to open up the bracket, we have 12 minus 9y plus 4y is equal to minus 8. So at this point, if we solve for this, we're going to see that we're going to get minus 5y is equal to minus 20, right? If you cross the 12 over to the other side, we have minus 8 minus 12. So therefore, my y is going to be minus 20 divided by minus 5, which is equal to 4. So we've got the first value. Now, we can now proceed now at this point to substitute the value of y into one of the equations. And it's very easy now to substitute the value of y into this equation we formed before. So let us now look for the value of x. So x now in this case is equal to 4 minus 3y divided by 2. So if we know the value of y, we can substitute that. So we have 4 minus 3 into, we just got y to be 4 divided by 2. And if we do that correctly, we should get 4 minus 12 divided by 2. So that's going to give us minus 8 divided by 2, which is minus 4. Again, you can go ahead to check, which we've done in the other, when we use the method of elimination, we were able to check that the right hand side of the equation or the left hand side of the equation is equal to the right hand side of the equation. For sure, this was satisfied because we got the same values as before. So this is pretty much the substitution method now, right? So let us now see if we can quickly go through the graphing method now and see how that works as well. So with the graphing method, it's very straightforward. You try to plot a graph and see where both equations, right, intersect. At that point, you have a solution, right, to the problem. So let us take, with the graphing method, with the graphing method, our aim again is to find the point of intersection. So let's say in this case we have an equation, an example equation. Let's say we have x minus y is equal to 0, and we have x plus y is equal to 1, right? So what do you do in this case? The first thing to do is always to draw a graph. And mark out some points. So let's see, we have 1, 2, 3, 4. So we have 5. We have 1, 2, 3, 4, 5. And we do the same thing on the other side. -1, -2, minus 3, minus 4, minus 5, and we have minus 1, minus 2, minus 3, minus 4, minus 5. Again, if you're using graphing paper, this is really very straightforward. It's easy to mark out those points, but in this case now we're just kind of using a freehand sketch to do this. So what do? You typically say, okay, let's call out one of the equations. Let's use one of the equations. So x minus y is equal to 0. We start off with when my x is equal to 0, what is my y going to be? Clearly, it's going to be 0. There's no doubt if you put that into that equation, right? So let's call this equation A. So again, if you proceed that way, so when my x is equal to 1 this time around, my y is definitely going to be 1 because x is equal to y from that equation. If you do the same thing here, x is equal to 2, therefore my y is going to be equal to 2. There's no doubt about it. You do the same thing as well for x equals to 3. You're just going to have y is equal to 3 as well. So similarly, if you do the same thing for the other equation, you have x plus y is equal to 1, right? Let's call this equation B. If you do the same thing, let's see what we get. When x is equal to 0, that leaves me with my y being equal to 1. And when my x is equal to 1, my y is going to be equal to 0. And when my x as well is equal to 2, my y is going to be equal to minus 1. And when my x is equal to 3, I should be having my y to be equal to minus 2. Okay. So with these now, we can now plot these points on this graph and find the points where they intersect. So let's start with the first equation. So when my x is equal to 0, my y is equal to 0. So if I'm to indicate that using a dot, I should be having, or a circle, I should be having the first point there. When my x is equal to 1, my y is equal to 1 too as well. So I should have a point that intersects somewhere there. I'll draw that with a dotted line. And of course, the same thing happens when it's 2 as well. So I can kind of mark that out there. I do the same thing when it's 3 as well. So again, if I trace this up, I should get the point somewhere there. So now I can draw a straight line that kind of connects those points. Okay, that's the first line now. And it's for the equation x minus y is equal to 0. Now, if we move on to equation B, it says x plus y is equal to 1. So again, when my x is equal to 0, my y is equal to 1. So if I step down and I say my x is equal to 0, my y is equal to 1. So that first point strikes somewhere there. So I'm going to use that symbol to indicate the second equation. When my x is equal to 1, my y is equal to 0. So when my x is equal to 1, my y is equal to 0. So I can strike it somewhere there. And now, when my x is equal to 2, my y is equal to minus 1. So I can step down a little bit and I can get somewhere there. Not quite accurate, but you get the idea there. So when my x is equal to 3, my y is equal to minus 2. So I should be able to get somewhere there. So if I draw the curve, the line, because it's not a curve since it's just a linear equation. So you can see that my point of intersection is somewhere there. Somewhere there. So, and you can see that, you know, just by looking at that, again, if it's drawn to scale, you would see that the value of x and y that should satisfy both equations would be my x is equal to just about half and my y is equal to half. So if you want to try that into the equation, let's check if that is correct now, just like we did before for the other two methods. So let's substitute the value of x as half and y as half. So if you do that in the first, so again, we want to check very quickly. So if you substitute the value of x and y into that equation, you're just going to get half minus half, which clearly is equal to 0. If we do that, the same thing as well for the second equation as well, we're just going to get half plus half, which again is equal to 1. So both equations are satisfied with x equal to half and y equal to a half as well. Okay, so that pretty much explains the three methods used to solve these kinds of simultaneous equations. Now, it's one question that you could ask very easily is what is the application of these equations, and where do we actually use them in engineering and sciences, right? So there are very many applications of this equation. So let's talk about why systems of equations are important and why you should know them, right? Especially if you're planning on doing engineering or sciences, right? There's so many applications I can think of for, let's just take a simple example, right? Let's just say, there's a strong relationship between the house price, the prices of houses, and the size of the house itself. So let's say we had some data that kind of was given to us that this is the price of a house is about $400,000, and the size of the house was probably, let's just say, 1,700 feet squared, and then the same thing as well. If we had some data that showed us that the house price was 500,000 and the size of the house was 2,000 square feet. So if we know this, right, so you can see that it's very easy to kind of say, okay, well, there's a good chance that this could have a linear equation, a linear relationship. So if we plot the value of a simple graph that kind of talks about the house price itself and the size of the house itself, right? If we plot the graph, we can kind of quickly see that, okay, well, if we have 1,700, we could have a point here which is about 400. So I'll use this in thousands now, right? So this axis is in thousands, and this is in, of course, feet squared. So if you do that, we have the first point, and if you do that, for the second point we have the value of about, let's say this is our 2,000, and the house price in this case was roughly around 500,000. So if we have that, we can kind of have those 2 points there, and we can kind of connect these 2 points. Now the question now becomes, what if I'm looking for a point, the house price, when the size of the house is about roughly, let's say, 1,850, right? So 1,850. So I'm looking for that one. What is going to be the price of the house, right? So I don't know what that is. So this is an example of the application of systems of equations. So we know that the equation of a straight line is y is equal to mx plus b, right? So in other words, if I'm to relate this with what we're doing, so the house price is equal to so the slope times the size of the house plus the intercept itself. We don't know what the intercept is, we don't know what the slope is, so this is unknown and this is unknown. So you can quickly see that, okay, we can form this as a system of equations. So if we put both of those points, we're going to have, the first one is going to be 400, again in thousands, is equal to m times 1,700 plus b. Can you see this? So this is going to give us something that looks like this. So 400 is equal to 1,700 m plus b. So we can call that now equation A. So if we do the same thing, we're going to have 500 is equal to m times 2,000 plus b. So again, if we do the same thing, we're going to get 500 is equal to 2,000 m plus b. Now you can see that we can now solve this system of equations using the methods we outlined before. Either you use the elimination method to solve it, or the substitution method to solve it, or you can as well use the graphing method. Even though the graph has been plotted here, you can find the slope of this line. It's very easy. Using the method slope is equal to y2 minus y1 over x2 minus x1, which again in this case y is the house prices and x is the size, right? Between these 2 points, you can use that to get that. So you can see this is one application of the systems of equation. There are many applications, right? In engineering and sciences, we do have some situations where we have to generate some equations for a particular system, and you will see that you come up with multiple equations, and sometimes more than 2 equations actually. Not just, we're talking about multiple systems of equation, multiple equations now, right? Which would make it really important that you kind of understand simultaneous equations or systems of equation, how to solve them. So there are many applications, and just off of my head, like there's so many. So it's very important that you learn how to do this. All right, at this point I'll stop here. I'll see you for sure next time. Please do subscribe and like, and we and let us know for sure any topics, any areas you want us to touch on, and definitely we'll do that.